Briefly talk about scalar and vector quantities. First, let's break it down to three words. We have scalar, we have vectors, and we have the word quantity. When you talk about a quantity, what do we say? We say quantity is anything that can be estimated. Anything that can be estimated or measured. Anything you can estimate or measure is termed as a quantity. Okay, we have various amounts of quantities. We have mass, we have length, we have time, and all that. They're all quantities. So you can group quantities into two various classes. Either we call them scalars or we call them vectors. Okay. So when we say a scalar quantity, what do we say? We say a scalar quantity is any of these quantities that have only magnitude. That have only magnitude. Okay. It has only magnitude. There is no direction. We don't deal with direction here for scalars. While for vectors, they have two things. They have one, they have magnitude and directions. So unlike scalar quantities, vectors have two things. They have both magnitude and direction. Okay, let me rephrase. When you say magnitude, what do we mean? I simply mean size. I simply mean size. Let me give you an example. Let's say we have a car. I can't really draw, so let me just give a little sketch. This car is moving with a particular speed. Let's say the speed of this car is 10 meter per second. Now, what am I showing here? I'm showing just the size or the magnitude of the speed, but I'm not telling you the direction at which the car is going. I didn't tell you the car is going this way or this way. I only said the speed is this. This value, 10 meter per second, is showing just the magnitude of the speed, but not telling us anything about direction. So for scalar quantities, we say they show just magnitude and no direction. While for vector quantities, they show both magnitude and direction. For example, again, I have a car. Now I say this car is moving in this direction, with a velocity of 10 meter per second. Now I'm showing you two things here. First, I'm showing you the magnitude. This here is the magnitude of the velocity. The magnitude of the velocity. And this arrow sign is showing us the direction at which the object, which is the car, moves. Okay, so we know two things now from this diagram. We know two things. One, we know the magnitude of the velocity of this car, and two, we know the direction at which the car is moving. So velocity is showing two things. Velocity is showing both magnitude, 10 meter per second, and also what direction. So we say velocity is a vector quantity. So we have other examples for scalar and vectors. Let me just give you some examples of scalars and vectors. For scalars, we have examples like mass, we have length, we have time, we have temperature, we have speed, we have distance, we have area. Those are a few examples of scalars. So let's see some examples of vectors. Okay. For vectors, we have examples like force. Force is a vector, which means that force have both magnitude and direction. We have electric field. We have moment. We have momentum. We have velocity. We have acceleration, and so on and so forth. To give you a little recap on what I just said, I said scalars have only magnitude. All right. That means they have only size. Okay. My vectors have two things. They have both magnitude and also a direction. Now let's note something. Now note that magnitude magnitude is represented using letters. So when you see a letter, that letter represents what? The magnitude of that quantity. Do you understand? For example, I have a vector. For example, I have a quantity. Let me say that quantity is represented as A. Okay. So this letter represents that quantity. So we have a quantity. You know what the quantity is? I said the quantity is represented as what? As A. So A is a letter, right? So I said now that letters represent what? Magnitude. That means that this A, what's it representing? It's representing the magnitude of this quantity. Do you understand that? So this A, since the letter is representing the magnitude of the quantity, note that we use letters to represent magnitude. Also note directions or direction is represented using arrows. Arrow. So when you see an arrow sign, something like this, or these arrow signs, we use this to represent what directions. So let's come back to the definition of scalar and vectors. Scalar has only what, from what I said up there, they have only magnitude. This means that, and I say magnitude, we use letters to represent magnitude, right? That which means that for a scalar quantity, you only see what letters. You won't see any arrow. Do you understand that? Why for vector quantities? Vectors have two things. Sorry, they have both magnitude, magnitude, and direction. They have both magnitude and direction, which means that they have both. How do you represent magnitude again? With letters, and how do you represent direction? With arrows. That means they have both letters and arrows. So, for example, if I have a quantity A and I put an arrow sign on it, because this representation now has two things. It has a letter and a arrow. Don't forget, letters represent magnitude, magnitude, and arrows, this arrow here, represent what? Direction. And what kind of quantity has both magnitude and direction? We call the quantity a vector quantity. I think that's clear. So if I have a vector B, how will you represent a vector B? Vector B represents like this. You write your B. B represents the magnitude of the vector, and the arrow representing the direction of the vector. But if I wrote just B, without an arrow sign, it means that this quantity has only magnitude, does not have a direction. So hence, B here, let me box that out. B here is a scalar quantity, while this is a vector quantity.